chain rule is used for finding the derivative of composite functions. So if I take the derivative of a composite function, f of g of x, the chain rule says that the derivative of this is the derivative of the outer function while the inner function remains unchanged, multiplied by the derivative of that inner function. So a few examples where I would use the chain rule. Sine x to the third, or maybe the square root of e to the x, maybe plus cosine just to make it a little bit more difficult. And do one more, do a simple one, something like x squared plus 2 to the fifth. And in fact, this last one I don't necessarily need to use the chain rule for this. I could just multiply all of this stuff out either by hand or using binomial theorem, and I would get I would just get a bunch of individual I would just get a very big long polynomial, and then I can do the powers individually or do the terms individually. But why do that when you can use the chain rule? So this is very easy to use. I'll just do an example and then it will be incredibly clear of what to do. And in fact, everyone who learns the chain rule loves the chain rule because it's so easy. So I'll do this one first. So I've got x squared plus 2 to the fifth. If I want to think about it really methodically, I'm going to think of f of x as x to the fifth, basically, and g of x is equal to the inner function x squared plus 2. And basically what's going to happen is I'm going to take the derivative of the outer function while the inner function remains the same. So I'm just going to ignore this part for the time being, for this first part, and I'm going to do the derivative of the outside. So f prime x is equal to 5 times x to the fourth. But the inside is going to remain the same. So far what I'm going to have is 5 times x squared plus 2 to the fourth. And now all that remains is I need to multiply it by the derivative of the inner function. So if I do the derivative of g prime, then I'm going to get 2x multiplied by 2x, so the answer is 10x x squared plus 2 to the fourth. And I guess I'll do this one really quickly as well, so this one's pretty simple as well. May as well. So sine x to the third. The outer function is sine x. The inner function, x to the third. If I do the derivative, this is equal to cosine x. Do the derivative of this thing. This is equal to 3x squared. So what am I going to have? Well, I'm going to have cosine and still this x to the third because the inside does not change. And then I'm going to multiply it by the derivative of the inner function, so multiplied by 3x squared, so this is just 3x squared cosine